Hey there, you're listening to the EmpowerTech Podcast with Iyari Cevallos. This podcast is where we discuss all things tech and explore the growing ways in how we can leverage technology to lead smart, sustainable, and impactful lives. Lauren Hanson is a senior mechanical engineer and leads the mechanical design behind advanced robotic hardware at CSIRO Robotics. She has led the mechanical design for several major projects, including DARPA Subterranean Challenge and the Multi-Resolution Scanning Payload, which has become both the first Australian payload with active electronics and the first CSIRO payload to be successfully deployed on the International Space Station. On today's episode, we talk about Lauren's journey through university into this field and what it's like to be a part of projects in advanced robotics hardware. Let's get started. Lauren, so excited to have you here today. I can't wait to get into some things around what you do, but I want to start at the beginning in terms of your journey. Can you talk to us about your journey from high school all the way through to now? If you can, feel free to jump through the years, but really keen to understand how you got to where you are today.
Oh, of course, and thanks so much for having me. So I suppose to start from the very beginning, as a child, I always loved science. I loved problem solving and learning how things work, and I really loved space. But throughout that, I really wasn't aware of engineering as a concept. It wasn't until I went to a university open day while I was in year 12 and contemplating what I wanted to study that I discovered that engineering was really just taking what we learned from science and applying it to solve real world problems. And I was totally hooked. That was exactly what I wanted to do. But I couldn't shake the science bug, so I enrolled in a dual degree of science and mechanical engineering at Monash University. And while I was there, thank you. Space always seemed very far off, difficult to do in Australia at the time. But the Monash Nova rover team kicked off when I was in towards the end of my degree, and we were a student team that designed and built model Mars rovers for competition in the United States and now in Australia. And it was a magnificent opportunity to really get my hands dirty with some actual engineering work that was outside of textbooks. And so joining that team was something that really reinvigorated my love for space, but also robotics and mechanical design. So I thought that was quite a big part of my university career.
Yeah, wow, fantastic. And Lauren, look, before you jump into more of that detail, I just want to ask about the double degree. What was it, just a general science and engineering, or because you weren't sure in that space, or was there something specific that you chose at that time?
So at the time, it took me a long time to decide what engineering I was going to do, let alone what science. I wanted to learn it all. So through high school, I took every science course that they would give me. And so at university, having to nail it down when I was but 18 was an insane choice. So I decided on mechanical engineering because I loved looking at how things move, which is quite a simplistic look at it now, but it was the right call for me.
Okay.
And with the science, I particularly enjoyed physics and chemistry.
Okay.
So I took both of those in first year, and I ended up with a mathematics degree. So I don't know what happened. It's not where I thought I'd end up with that particular degree.
Okay.
But I did really enjoy the subjects at the start, and yeah, just followed it on through.
Okay, perfect. And you were talking about some more hands-on things that you were getting to do during that period as well.
Absolutely. So because it was a 6-year degree by the time everything was said and done with the double degree. In my 5th year, I think I joined the Monash Nova rover team, and I got some hands-on experience building those model rovers for use in the desert in Utah in the United States, which was a huge opportunity and quite a lot of fun to work with such passionate students who were giving up their free time when they possibly should have been studying or doing gosh knows what. We were in the workshop designing bits for a robot that was a lot janky and held together by feeble student hopes and dreams, but we ended up doing quite well. We're the first Australian team to be accepted into the competition. Endlessly proud of the work that went into that. And throughout our work, we coined the term "it's not done until it's tested." I know it's probably everywhere you look, but for us, it was something that we learned through a whole bunch of trial and error, and it's something that I've carried through with my career, and I don't think will leave me anytime soon.
Yeah, wow, that must have been an amazing experience. Did you get to talk to, communicate with people at NASA for that project, or other students in other places?
With that project, we did while we were over at the competition. It was quite a collaborative environment when all the people were together, in that people would bring their robots along and you'd be able to wander around and point to people's designs and ask them questions about why had they made their wheels that way? What was the ethos, the design ethos behind this suspension choice, or why does your arm look like that? That kind of thing. And often people were quite open. But now there's the Australian Rover Challenge, so that didn't exist when I was part of this rover team. But it happens in Adelaide every year.
Okay.
In about March, and that one I've been down there, and it's incredibly collaborative because their tents for the student teams are right next to each other. Students are just wandering around and really willing to help each other out. It's not a me versus you kind of competition. It's everybody's in it for the love of robotics, it feels like to me as an outsider, and that's so positive to watch.
Yeah, that sounds amazing. Lots of learning happening there. And when you did that competition, you said it was the first time that Australia had been a part or something like that. Was it on top of your study? Was it something that they were calling volunteers for, and you sort of put your hand up for it?
Yeah, kind of. So it's a student team similar to, there have been student teams that build race cars for FSAE teams for a very long time. So it's very similar to that in that you take it on top of your studies. It's fairly voluntary, and people really get involved the experience is great for employment afterwards, but a lot of the people I was dealing with were in it for the love of robotics, and because it's the kind of thing they wanted to tinker with in their spare time anyway, and having a space to do it at university so you could just duck off for a lecture here and there was the dream, really. So it was also helpful for building such a community of like-minded people. Yeah. And were there, in terms of your student cohort, were there many girls as well as boys in the class? Like, was it fairly even at that point? No, so there were about 14 of us, and 3 of us were women in that particular team. But I think they've made quite a bit of a shift lately, and I know in recent years their leadership team has been sometimes more than 50% women, which is magnificent. They're doing a great job. Okay, that's right. And there are now these teams popping up at universities across Australia. We not just at Monash, which is fabulous to see as well. Love a bit of competition. Yeah, that sounds great. Okay, and you mentioned mechanical engineering. Can you tell us a little bit more about what the difference is in terms of how you've studied that versus other engineering kind of disciplines, just so that we all are on the same page about what that is? Yeah, for sure. So when I was trying to decide, I didn't know. I thought, look, mechanical engineering is probably like physics, and chemical engineering is probably like chemistry, and I really wasn't that close. A bit similar in that mechanical engineering does involve some of the concepts behind physics, but it's not anything like a physics degree. But it's I suppose the reason I did end up choosing it was because it's just so broad. You can do quite a lot of things with a mechanical engineering degree, and I didn't want to pigeonhole myself immediately. Okay. But what my mechanical engineering degree does for me, so what I've used it for is to become a design engineer. So I use it to design hardware and components and assemblies, systems to solve a problem. So, for example, at the moment, I'm designing robots, but at the past, after I graduated, I joined Gilmore Space Technologies and was a mechanical engineer there, where I was designing rocket engines and test stands and the like. So sometimes sometimes it's parts that move, and sometimes it's tables that stay still and hold a rocket engine while it fires. It's quite broad
variety
within what I do, but that's a small part of the pie.
Yeah, very big variety there. And when you looked to leave university, what were your choices at the time?
Well, there were quite a few options that I was looking into, but what I really wanted to do was try to find a way to break into the space industry, which seemed difficult and definitely competitive. But I was looking into roles with some great companies, but I ended up, as I said, joining Gilmour Space Technologies, largely because they were such a small team, but their goals for Australia's first orbital launch vehicle is so inspiring, and it was just something I couldn't say no to be able to contribute to something like that.
Yeah, wow. And you mentioned that it's quite competitive. Is that because we're based here in Australia and we don't have as many programs?
In part, I think so, but also things like space are wonderful because they can capture your imagination from a young age, and there's a lot of people who are just so inspired by the idea of space and exploration and everything like that. So the idea of being able to work on something that also inspires you, I think, is captivating for everybody. So I can definitely see the appeal. I mean, obviously I can see the appeal. It's something that's driven me, but I can see why there's a lot of competition out there. It's quite captures your imagination.
Yeah, wow, okay. And so you started with, someone after university, and did it meet your expectations, Lauren? What was it like?
What I loved about it was that when I joined the team at Gilmour Space Technologies, they'd just taken on 5 mechanical engineering graduates, and it was not entirely dissimilar to the work I'd been doing on the rover team. I mean, rovers and robots different. So rovers and rockets are obviously different, but the community of having gone from a group of people at university wanting to solve this problem because they loved it to a group of people now having an office job trying to solve problems also in the space industry because they love it was magnificent. It was what I'd wanted for people to join a team of people who are passionate about what they did, and that was great. And it was the people who were already within the company were so wildly talented that being surrounded by people that you can learn so much from was such a fantastic experience.
Yeah. Yes, I can imagine being in that sort of environment. It kind of doesn't really feel like work.
Look, I mean, I think the idea of if you do what you love, you never work a day in your life is one that I'd love to follow, but there's certainly days that still feel like work because a lot of what I love about my current role was there at Gilmour too, in that there's a lot of fun problem solving, there's a lot to tinker with, but there's a lot of other work around the scenes that you've got to mess with, like tolerance stack-ups and some of the parts of mechanical engineering that aren't as much fun, and Excel spreadsheets and budgeting and whatnot.
Oh, Excel.
There's plenty of other things going on. Oh, yeah.
So what would be a typical day when you started versus later on in your journey?
A lot of what I was doing when I started was, and I suppose most of the time that I was there, I was spending a lot of time in SolidWorks, which was our CAD modeling package. So the software that you'd use to design rocket parts. And it was a room full of engineers who'd often have this software up sitting around designing parts, which was magnificent, quite a lot of fun. Or we'd be in a room chatting about designs, design ideas, and floating around how we could do something better. And there's something that was really special about having people with the same kind of skill set in the same space, because we all bring something different to the table, which meant that we could get better results because we had a team of people who were trying to solve a problem rather than just running at it alone and not asking your colleagues for guidance. So there's a lot to be to be learned from that.
And how is that different to what you do today?
A lot of it can be a bit similar, but what I do today, because I'm at CSIRO these days, I'm working on robotics with their robotics groups, and so the biggest difference is obviously rockets and robots are different, but also I'm with a research group. So we're not working towards building a rocket for a company that's building a rocket. We are instead more of a research provider for industry and the Australian people. So we're not working on just the one project. I've been there for around 5 years now, and I am constantly working on different projects. So I think the biggest thing for me is the context switching in a good way, in that I'm able to apply my skills to a bunch of different industries like space still, but also unmanned ground vehicles and medical robotics and the like. So there's just this huge amount of breadth, which requires a huge amount of understanding of different different requirements.
Yeah, wow. And with your job today, what are the things that you have learned along the way in terms of people wanting to get into this type of work?
I'd say the biggest one that I keep learning is something that I touched on with the Nova Rover team, is the it's not done until it's tested part. But in robotics, I think we've gone a step further with that in my work with CSIRO, and that's more of the integration testing piece. It's not about just testing my mechanical hardware, putting it on shelf and saying that's it, the robot's done because I've put it together. It's about making sure that while there's many different people working on a project with a bunch of different skill sets, we're constantly coming back together and making sure that what we're working on works together. Mm-hmm. So we're not each running and diverging in different places and then having to spend months on integration at the end. We're always making sure that what we're doing works together.
Okay. That sounds like a lot of teamwork.
Yeah. and communication with people who it can feel like they fundamentally speak a different language to you when you've got different specializations. So for a long time, I was the only mechanical engineer in our robotics team. We now have another fantastic one. There's two of us, but I was the only mechanical engineer in a team of some electrical engineers, some mechatronics engineers, but a lot of software engineers. And it meant that I was initially, after I joined, in a lot of conversations that I didn't understand. And I've been learning as I go, but there's a lot of having to break down and what I'm trying to explain and what they're trying to explain to me, and making sure that we're fundamentally understanding each other to the extent that we need to.
Okay, so a lot of translating, I suppose, or slowing down to get the work done. Yeah, okay. That doesn't sound dissimilar to other types of teams where there's lots of different people with different skills. And in terms of the projects that you are working on today, which are the ones that you're most excited about?
At the moment, I'm enjoying working on robotics in a mobile manipulation space. So we're working in arms on robots, so mechanical and electric arms, being able to grab things on a platform that's moving, essentially. So there's a lot to be done in that space. But in terms of my recent work that I've perhaps been the most proud of, the work that I've been doing for the last several years was on a project called the Multi-Resolution Scanning Payload, which is a bit of a mouthful, but we call it the MRS. So I will no doubt slip into calling it that quite quickly. But that's a small scanning payload that's currently on board the International Space Station, and became CSIRO's first payload on the International Space Station, but also Australia's first payload with active electronics to be deployed up on the ISS. Okay. So it's been a huge personal milestone for me, and I know for the rest of the team as well.
Sounds fantastic. Now, first of all, can you explain why we call it a payload?
Look, we call it a payload because it's a bit of nomenclature for something that we've sent to space. So I guess it's a bit of a shorthand for that. But it's also it's the sensors and compute, this payload, but it doesn't have its own batteries or propulsion system. It uses the NASA's Astrobee robot, which is about a 30-centimeter cubed-shaped robot that is fan-propelled and flies around the International Space Station, and is intended to help astronauts with tasks and whatnot. Okay. So our robot our payload latches into this robot, and then it's moved around. So in another way, it's a payload there as well.
Okay. And you said it moves around to help the astronauts. What is it doing?
The Astrobi does. So it's got a different payload that it can have on there that's got an arm, and it can perform some basic tasks. It can also have payloads like ours latch into it and perform some experiments in microgravity. So that's what it did with ours. Mm-hmm. Our payload latches in, and then the Astrobi moves around the GEM module on board the ISS and allows us to take scans.
Okay, so scanning technology as well.
Yeah. So our payload specifically is scanning technology. So it combines a bunch of different sensors and some algorithms to provide really detailed maps of the space environment. So it can see how things are at the moment, where they are, how they change, and also keep track of its position as well.
Okay. And in terms of that project that you did, was it mainly an Australian team that then, when you were ready, were communicating with the other teams to be able to, get this up into space?
So this project was where I worked within the CSIRO portion of the team, and we were a combination of a couple of different business units within that organisation. But we also developed the payload in partnership with Boeing and in collaboration with NASA and the ISS National Lab. So we did work very closely with NASA on things like safety requirements, because if you're sending something up to the International Space Station, there's astronauts up there and quite a lot going on, and you need to make sure that whatever it is that you're sending up doesn't pose any threat to what's already up there. So things like flammability and sharp edges out there, really tightly controlled, absolutely with good reason. So there's a lot of collaboration there, but also around things like testing and whatnot. So our vibration testing, we were working with them, but also we did take the payload over to the NASA Ames facility in San Francisco and test our payload in there. They've got a mock-up of this Astrobi robot that I was talking about on the ground. So they've got it in what they call the Granite Lab. And so you can take your payload and latch it in there and test it in a real Astrobi without having to send it all the way up to space first, which is hugely important, because the first time that you test something, it's best not for it to be when it's already in space and you can't touch it and try to fix it. So that was a fantastic opportunity to be able to go and do that. So we did work closely with NASA on things like that.
Yeah, I never really thought of that in terms of, once it's up there, you can't really, maintenance isn't the same as what it is here in terms of getting things fixed. Is it
absolutely?
Is it black and white? Are you not able to fix anything at all? Does it have anything that communicates with tech there or anywhere else?
So the intention behind that is, I'm the mechanical designer behind the payload, so it being able to work without needing any kind of maintenance was kind of my was on my shoulders. So we are not under any assumption that if anything goes wrong, that we have the astronaut time and the like for them to be able to take the lid off and see what's going on. It's just it's difficult to be able to communicate that effectively with procedures, particularly with people who've never been involved with inside the payload before. But also we can't really be asking them to start undoing bolts and the like, because it's not a gravity environment where the bolt will just sit on the desk. We will have little M2.5 or M3.5 bolts floating around the International Space Station. That's not good for anybody. So in general, that's not something that we would be looking into. But the intention is that won't be needed at all. But I can tell you that when the payload launched in March of 2024, it's not like after it had launched, it goes up and we're immediately testing. They do unload it, and then we have to wait until our allotted astronaut time. So there was months where for me, I couldn't touch the payload anymore. I'd bolted it up, handed it over, and I'd seen it go up in the rocket, and then I had to sit and wait and assume and hope that when they plugged it in, all of the sensors would be online, all of the cables would have been fine. So that was from March to August, quite a stressful time in my life, if I'm honest with you. But thankfully, all of the we have done the testing and everything's looking fine. It's all mechanically sound, which was quite the relief.
Yeah, wow, that's very different to something here. And I assume, during that time you were doing your best not to think about it too much. What is it like now for you, in terms of your, the work that you do? Would you want to do another program like that?
Absolutely. In a heartbeat. I think there's a lot to be said about the team dynamic in a project like that, because the effect of working on a space project with other people who are perhaps this nerdy about space is really difficult to explain. People are so passionate about the work that they're doing that we would get caught up in conversations about trying to problem solve things, and it didn't matter about any distinctions between my job or your job. Everybody was trying to help however they could, and it was quite a collaborative and fun and friendly and really quite motivated environment to be working in. It's quite a passionate team. It was really great to be working with. So I'd absolutely jump to work in a project like this again.
Sounds amazing. We're coming to the end of our time together, Lauren, and I'm just wondering, for our audience, if they want to get more familiar with this type of work, where can they go to find information, either just out of interest or around, potentially looking at this as something that they want to do in the future, but maybe some parents that are looking for their kids. I know that it's coming up to that time of year where people have to pick things, which is quite stressful. What would you suggest?
Look, in terms of information about projects like this, I know CSIRO post quite a number of articles about things like this, sometimes on their LinkedIn or Facebook, Instagram pages, but also on their website. And I'll provide a link for you. But outside of that, I'd say perhaps more than trying to specifically talk to my part, something that really guided me was following my curiosity. So it was about following things that problems that stuck in my brain like a splinter and were really a joy to solve, and working out what it was about those problems that I really enjoyed, and then trying to turn that into my career. I think has been quite successful in terms of those problems become the projects that I'm most proud of, and the work that I think I've done that's ended up with the best results. So I think that following things like curiosity is definitely something that I would advocate for anybody who's contemplating what it is that they're doing at university next year or looking for a new career.
Yeah, it's a great tips. And I want to thank you for coming on. I really was excited to hear about some of the things that you've been on with, and these sorts of projects you don't often get to hear anything other than what you might see on the news or the information that we get these days. It's a little bit tricky to find things sometimes. Any other top tips for our listeners in terms of empowering themselves in this space? Maybe engineering, or you mentioned quite a few of them today, and the differences, or potentially seeing what CSIRO does in those projects. Is there anything else that we should know about?
Well, look, I'd say if you're a university student listening to this, I can't advocate highly enough for joining things like those student teams. I think it's helpful in terms of understanding what it is that you like about a problem, but also it's if you're lucky enough to have the spare time to be able to devote to it, it's a great way to help give yourself a little leg up when it comes to trying to snag that graduate job that you're really interested in.
Yeah, fantastic. Thank you so much for joining us, Lauren. It was great to have you today, and we will speak to you soon.
Right, thank you very much for having me.
Thanks for listening today. Do keep in mind that this is a podcast for informational purposes, and all we're really doing is sharing our opinions on things that matter to us. With that being said, if you liked what you heard and want to continue supporting us, share this podcast with your network to help us grow and bring on even more guests. Until next time, this is Iyari from EmpowerTech, signing off.